I hope everybody had a good lunch, had enough soup and bread and stuff. We're still waiting for the projector to find the laptop of Jeroen. We'll see. But I'd like to introduce Jeroen. Jeroen Bastijns is a software architect at Ordina Belgium GeoWorks. And Jeroen has a very broad interest in application development and cloud and DevOps. And I know Jeroen also has a front-end background. Recently, Jeroen has become interested in the issues that arise in event-driven architecture, particularly event data evolution, consumer compatibility, and event exposure. So, if the software is gonna work, okay. Let me ask some questions. So, who has already worked with event-driven application or developed event-driven applications?
Okay, that's a couple.
Who have never heard of event-driven applications? Okay, one Jeroen. Who knows how to work a projector?
All right. Finally, sorry. My talk is going to be about contract-first, event-driven APIs. Like Peter said, my name is Jeroen. He introduced me very well. Let's first set the stage for event-driven. Just a quick recap. A typical event-driven architecture, usually you have a service which publishes some event somebody else in your organization wants to consume. So that's a producer. It will publish that event on a message broker. In this case, I took Kafka as an example, a Kafka topic. And then you have the consumers who are interested in your event, want to do some action when an event happens or build some other business capabilities upon that event that happened. The event data, usually it's in a JSON format, and events are typically named in the past tense, so employee attended join. Just simple recapping here. So when you architect event-driven architectures, usually start in a development first flow. That's at least how I learned it a couple of years ago. So when you develop first, you create your event data in your producer. And you have a version 1, so the first edition of your event. You publish it to the topic. Your consumer will consume it, and everything runs peachy. You're happy that your event is consumed by your consumer or consumers. Now, time evolves, your event evolves, you get a version 2. This version, you just add a field, which your consumer could ignore if it wants to, and otherwise implement or do some implementation with that new field in your event. But it's a compatible change. Nothing breaks or nothing is broken in the consumer side. Now, of course, you're gonna have a version where something will break. You will remove a field. Maybe you will change the type of a field. For example, if you have a field which is a date, you have it in epoch time, and now you changed it to a formatted string for that matter. It will break your consumer because it cannot consume that message anymore. It doesn't expect that the field isn't there. Probably the consumer removed the field because it thought it was optional, but it wasn't described in the documents the producer gave to the consumer to consume its event. There's a couple of ways you can solve this issue. You could, of course, stay compatible forever. You cannot change any fields, or at least cannot remove fields. You certainly can add fields. And if your consumers stop consuming that version, you could eventually remove that field, but you need to be in close communication between your consumers. As a producer, you need to be in close communication with your consumers. The other approach to prevent this is to add versions to your event, typically in the event data. So you publish your event with a certain version on the topic. Your consumer implements some handlers for each version. If it doesn't recognize that version, so it can't handle it, if it's a possibility, it could store it to a database or somewhere else to handle it later on when there's time to implement handling for that new version of your event. Other ways of solving this issue is, as a producer, I have to publish different versions of my event to the same topic. Again, my consumer can choose which version he will like to handle, and he could ignore the unsupported events because he knows the producer will still send those events in a version he could read. Another option is to use multiple topics. So whenever a new version of your event is produced, or whenever a breaking version of your event will be produced, you use a different topic, but you still send out the different versions of the event, so your consumers can choose which topic to listen on and still consume your event. Now, as you can see, evolving that event data is hard. The architecture is not that simple. The next thing I want to note is there is no discoverability in a sense that you could see at the message broker which events are published, and you could see, okay, I want to build some new business capability as a consumer on those events. But there is no real description of your data. You can only ask the producer, of course, to hand over some information on how to use that event. Or there's also no documentation on typing. So which fields are in my event, which type is that field? Is it an optional field? There's nothing really there to guide you. So there's room for misinterpretation as well, in the sense that, of course, you have your event data, you have some fields in your event, but your consumer cannot distill the context of that field. There could be a date in the field, but what kind of date is it? Is it a creation date? Is it an update date? Is it something else? You have no documentation on the context of the field with just regular JSON as payload of your data. How do we want to solve this? By using a contract-first approach to create reliable systems, consistent systems, and of course also typed event data. So as a consumer, you could discover how the event will look like, how you can build upon those things, and also as a consumer, you can have more reliability in the sense of compatibility. So when the producer creates a new event, you can be sure that it won't break your consumer code, at least not in a certain version. In event-driven architectures, the event data is the API. So basically, everything that's in your event fields, I mean by that, describe the API of your async communication. So it's basically your contract you need to live by. In event-driven architectures, there's a lot of things you have to worry about. Like I showed before, versioning is an issue, documentation is an issue. Those things are usually an afterthought. You start with the basic development first approach, and afterwards you start thinking about versioning the event to solve issues at the consumer side, plus documentation. You provide more context to the consumers of your event. Message brokers are not aware of data types, so they can't, for example, say that an event is wrong you put on the broker. They only know binary, plain text, or JSON format. They can't enforce anything. And you need to be sure message structures are bound to evolve over time. So fields will be added, removed, made optional, change types. You really have no snapshot of it, actually. It's always in flux. The first thing we want to do when we want to provide a contract for our async communication is provide a schema as a way of defining the contract. In this case, you have two options. You can use schema specification or schema-based data serialization. Schema specification is basically, in the case of JSON schema, you will still send your event as a JSON payload, but you just provide a JSON schema to describe how your JSON payload will look like. So which fields are in there, if they're optional or not, what kind of values could I expect from my field, if in case it's an enum, for example, documentation, examples. In schema-based data serialization, it works the same way, so you still have to describe a schema. In this case, you could use Apache Avro or protocol buffers, but the data itself probably isn't JSON anymore, because data serialization libraries such as Apache Avro and protocol buffers, they serialize your data from that schema structure, not to JSON, but probably to binary structure. The reason why they do that is it's much smaller, so you have the added benefit that transmission times are much faster because there's less payload going over the wire, and also you have a lesser memory footprint or disk footprint on the broker, for perhaps. Voilà. This is a slide just to give you an example. So on the left you have regular schemaless JSON payload. It's non-schematic. On the right side, I created some pseudo schema, so it could be Apache Avro or protobuf, where you describe what the event is. In this case, it's an employee. It's of type object, and you can describe the fields that are in your data. You can also specify the typing and even specify specific complex types, such as union types, where you say age is an optional field because it could be null or, in the other case, an integer. Just to emphasize the data is smaller, I created a block below that where the data is serialized. The first thing you notice in binary, and especially in those frameworks or in those libraries, Apache Avro, where you use data serialization, you don't need to specify the fields. So that's what I mean, that the data structure is much smaller. In JSON, you have to provide your field name. Once you serialize your data with the schema, with Apache Avro in this case, you don't have to specify the fields anymore, so your data will be smaller going over the wire. Talked a lot about Apache Avro. Why? Because it's the preferred serialization framework for Apache Kafka. It does support some other stuff as well, such as JSON schema and protobuf. But Apache Avro has a compact serialization format. You can separate the schema you define from the message payload. It has strong data typing, and you can provide really complex data types for your event data. And it also supports schema evolution. Now, why is schema evolution so important? Because you have your version 1 of your event data and you write a schema for it, so how your event data is structured. Schema evolution means you will evolve your event data, so you also evolve your schema, so the structure definition of your event data. And if schema evolution is important because you can ensure compatibility between two versions of your event, so between two versions of your schema, if that's clear. What does an Avro schema look like? How does it look like? You can provide a namespace. Usually it's the organization where your schema will live. Type is record, which means it's an object-like structure. You can provide a name. In the demos I will give, the event I will publish is vehicle refueled, so your vehicle will be refueled somewhere. You can provide fields for the data payload of your event. In this case, I had a license plate, fuel type, and fuel amount. You can specify the type. You can specify extra documentation, so giving more context to that field. And also complex types, such as an enum, where you can provide the symbols. So your consumer will know what the possible values are of that field in the event data. And in fuel amount, I used a default, which basically means that your field will be optional. So if I don't provide as a producer a value for the fuel amount, it will default to 0, and my consumer will still get value 0 from my fuel amount. All right. So we took the step of defining a schema, so a contract for event data. I want to store that contract somewhere, my schema, and that's where the schema registry comes into play. It's the place where you will define your schemas, you will evolve your schemas, so describe your new version of your event data, and also as a possible consumer of events, you can look up schemas, so you can see which events exist in which version, so what the data payload is, what the documentation about the event is. So as a possible consumer, you could see what business capabilities you can build from the existing events in your organization. It has built-in schema validation, so once you write a schema, you can get syntax validation, knowing your schema will be correct. It can also enforce those compatibility rules. I will talk about it later on. And it gives you a unique schema ID. Now, why is that schema ID so important? I don't want to send my schema with my event data all the time over my broker. So the idea is that you upload your schema to the schema registry. It gives you a unique ID, and I can send my data payload, so my event data, along with the schema ID, so that my consumer can look up the schema in the schema registry and deserialize my data back to something like a Java object. What types of schema registries are available to use? You have the Confluent schema registry. Confluent is very known in the Kafka space. They also have a lot of tooling written for it. That schema registry already exists for 6 years, so it's not very new, but it's the most, I guess it's the most advanced one. The other option is API Curio. That one is not specifically written for Kafka, but it's interchangeable with the Confluent schema registry. And of course, you have some cloud provider specifics schema registries, such as AWS Glue, I guess, and Azure schema registry. So I've talked about schema evolution, so evolving your event data and new versions. Schema evolution is checked on the schema registry, which basically means you want to evolve your schema on the schema registry, so you will upload a new version of it, and the schema registry is the single source of truth. It will check if your new schema will be compatible with the previous one according to the things you configure for your schema. Schema compatibility, so how will it check if it's compatible, your new version of your schema and the previous one? You have some options. You can have backwards compatibility, forwards compatibility, full and none. Backwards compatibility means that if the consumer uses your newest version of your schema, the producer could still send events with the previous schema version, and the consumer could still consume them. So it's more of a consumer-driven way of doing event data architecture. The forward one is the other way around. So your consumer, using the previous version of the schema, could still read data produced by the producer with the new version of the schema. So it checks that compatibility. Full compatibility means it's both backwards and forwards compatible. None means you don't check any compatibility at all when you define schemas. There's also something called transitive. Now in the previous slide I said you guarantee compatibility between your current version of your schema and your previous one. Transitive means across all your previous versions of your schema. So it's much more restrictive to what you can do. But there are some cases where you want this. So I just mentioned it. Now, I guess the most times you will use this, you will use just backwards and forwards, not transitive, because you want to move a little bit between schema versions. So remember, backwards compatibility means actually, as a producer, I need to wait that all my consumers are updated to the new schema before sending event data with the previous with the new schema. And forward compatibility means that the producer has the ability to move forward much faster than the consumers, where you can gradually introduce breaking changes in the next versions. I will show you something later on in a demo. Okay, now I'm gonna demo the schema registry. What I have here is the same contract I showed you before, so vehicle refueled. There are some extra fields besides the one I showed you. You also have a fuel unit and a city where the vehicle is being refueled or has been refueled in this case. This is the Confluent schema registry, actually the Confluent control center. You can do lots of stuff here, create topics, whatever. I've created a topic for vehicle refueled. You have an option here to define your schema. So I haven't set any schema yet. Now I can choose between JSON schema, Avro, or protobuf. It always generates some example, but I'm gonna just override it. So I'm just gonna paste my schema in here for my event. I can have the ability to do syntax validation, and I will create that schema. Voila. Now for this topic, I have defined a schema. You can see that I have a schema ID now, and my compatibility mode is backwards compatible. Now for my next demos, I will change this to forward compatibility. I can do this, so you see all the options here. And then of course I need to save. To show you that now in forward compatibility mode, I need to be sure that I'm compatible with my producers. So in this case, if I just delete a field, in this case city, it should not be possible because my consumer expects that field. It's a required field. You can see that it's not an optional field because it doesn't have a union type of null and string, or it doesn't have a default value. So my consumer will expect that this exists in my event data. So what I need to do is evolve my schema into a new version. And when I delete that field in my schema and I try to validate, you can see that my schema registry just can't let it pass because the compatibility rule is forward, and the schema I want to evolve to is incompatible with the previous schema, so with the earlier schema for the subject. Back to the slides. So I've showed you how you can create a schema, showed you what a schema registry does. Let's look at the flow for such a contract first implementation. So we defined the Avro schema in this case. We've uploaded it to the schema registry. The first step you could do is have a built-in validation of the local schema. Now, why do you need a local schema? You will have the same schema in your schema registry as locally in your producer, because in this case, I want to generate from that schema a Java class, which I can use to structure my event in my Java project, actually. I will show you in a demo later as well. The upside of it is that I get compile time errors if there are fields that don't exist, of course. But I need to make sure that my local Avro schema, which I use to generate my Java classes to generate my event, is the same than the version in my schema registry. Second thing, now we're at runtime. What happens? I generate my event in my producer. I use a specific Avro, Kafka Avro message serializer. What does that serializer do? It will look at my local Avro schema and it will validate that one again against the schema registry if it's the correct one. If it is the correct one, it will use my schema ID, my unique schema ID from my schema registry, and it will produce that message with the schema ID to my broker. So it will publish it on my broker. At this point, the broker has my serialized data and the schema ID of the writer, so my producer in this case. Next step is, of course, my consumer, which want to consume that data. So it will first retrieve the writer schema, because it could be another schema than my consumer has locally. It could be the previous version or the next version, depending on your compatibility settings. And then it will first check compatibility with that writer schema. If it's compatible, it will consume the message, and it will, in case of my demo later on, it will deserialize my message to a Java object. In the other case, you will get an exception in your consumer that you cannot read that data because your schema that's been used to write the data isn't compatible with the one that wants to read it. Let's look at a demo again. So you've saw the schema. First thing I'm going to show you is my producer. I have a Maven POM where I have the Avro Maven plugin. What it does is it uses my initial schema, so my first version, and it generates the necessary Java classes for it. I have a vehicle controller. It's just a REST endpoint where I post something to refuel my vehicle. The most interesting part of this is the vehicle refuel. So this is the Java class that is generated by my Avro schema. Now if I open it, you can see it's Avro generated. And it generates the Java class, of course, from my schema. It also provides me a builder, so I can simply build up my event data according to my schema. And once I've done that, I will send it to Kafka. So let's start my producer to show that. Okay, it started. Now I'm going to send some REST posts query to the controller. Okay, that worked. If I now go back to my control center, I can look at my message. And I can see my event is stored on the broker. Second step is the consumer, of course. So in my consumer, I have a simple configuration which just uses the same Maven plugin to generate a Java object. So it's the same vehicle refueled generated by Avro. In this case, I just will log the toString value of my vehicle to prove my point that I can consume it. So if I go to my consumer application and run it, it would probably consume my event. So this is my event. You can see everything is in my event, my license plate, fuel type, fuel amount, fuel unit, and city. Oops. So the next thing I want to do is I want to evolve my schema in a new version. So let's do that. In my producer, I can use with city optional. Let's go to that schema. So what I've done here is I adapted my schema and I made city optional by providing it a default, so the city will be unknown. And I now want to have a location with some more specific coordinates, so you can see I can define some complex types as well. What I've also done is, that's a feature of Avro, you can add Java annotations. And in this case, I've added deprecated to it, and I say since version 2 of my schema, this field will be deprecated, and for removal true means in the next version it will be removed. That's just an interpretation of the deprecated Java spec. Okay, now I need to evolve that schema, of course, first in my schema registry. So let's go to the registry, evolve schema. I'm just gonna paste it here. So as you can see, my location is now in place, and city will be an optional field. I can validate. I see validation is passed, so I know it's compatible with the previous version of my schema. I'm not breaking anything for my consumer. I will save it. I get a new schema ID, so the new schema ID is version 2. Then the next step I need to do is stop my producer. And I need to do a Maven build again because in my POM I now switched to the new version of my schema. So let's just do a quick Maven clean verify. All right, we're there. Let's go back to the controller. So I've adapted my schema. I've generated a new Java object, and you can see here I've got my nice Java deprecation notice. You can also get it, of course, in your consumer when you use version 2 of the schema there. So your consumer is actually in the code notified that the event data is changed and that city will be deprecated and marked for removal in the next version. I don't want to send city anymore as a producer because I don't care and it's going to be unknown. But I do want to send my coordinates. Let's import coordinates. Okay. Then I just need to start my producer again. Okay, so now it's using my new version of the event data. If I send a new request, so I can generate a new event. Okay, all looks good. I can actually see in the consumer, because it's still running with the old version schema, I can see that my city is now unknown. I'm just using the string value of my my object, but you can see coordinates is not available because in the consumer it still uses the previous version of the schema. So I could update it now there as well, and then you would see coordinates, but I'm not going to do that anymore in the demo. So let's go back to the slides. Whoops, wrong slides. So to summarize, you have a central schema registry where you can evolve your schemas in a confident manner because you have the validation there, and there's different approaches available for schema evolution. You can go forward compatible, backwards compatible. You have the compatibility checks in the schema registry, but also in your serializer and deserializer, so in producer and consumer. And you have the ability to design the contract first, which means you can first provide the contract and both teams, so consumer and producer, can already start implementing it by using the Avro Maven plugin to generate Java objects, and maybe even test tooling or mocking on specific topics in Kafka, so you can already start testing your implementation. So we can now evolve event data in a compatible way. We're sure that it's going to be compatible. And we have discoverability through our schema registry, so we know what the event will look like, what events are available, some extra documentation on the fields. And we have support for multiple versions of our event data, depending, of course, what compatibility you choose. This was all I had. I'd like to thank you for listening, and if there's any questions, I will gladly try to answer them.
Ik had een vraag voor als je nu verder zou gaan uiteindelijk, want je zegt oké, ik maak nu city optional, dat is leuk. En de volgende stap, want je evolve schema laat niet toe dat je non-backward compatible bent. Hoe moet je het dan doen? Als je city zou effectief in de volgende versie verwijderen, dat vroeg ik mij nu af.
Heb ik nog tijd?
Tuurlijk.
7 minutes? Ah, okay. Mike, I can show you as well. So the next thing would be, but I'm not gonna do all the things, but I'm gonna just show you the schema. So now I've made city optional. The first thing I have to do is now in the consumer use version 2 of my schema as well. So it's optional there, and the consumer will know that it's gonna be deprecated in the next version. So now I still, as a producer, of course, no. Once the consumer uses that new version, I can delete my field in the producer because now it's optional, and the consumer has the new version of the schema, which means that if the producer doesn't send the city anymore with schema version 3, the consumer will just use that default value unknown, so it's not broken anymore on the side of the consumer.
So if you added in the schema registry, you have to change then to none?
No, you don't have to change compatibility.
So you can just put the new one without, and then it's still compatible, it says.
Yeah, so in forward compatibility,
Yeah.
you can't delete required fields. City was initially required. From required, I made it optional in the second version. So once my consumer is on the second version, he knows it's optional and he has a default value. That's of course the important part of the thing. And once that's done, yeah, you can just delete the optional field in version 3. Your consumer can already send events without city and with only the location in place. And the consumer is not broken because he has a default value for it. So that's how you can, I guess, in forward compatibility, it's much easier to just do it that way. So you can gradually evolve your event data to something you want as a producer, because the field is not important anymore to you, but maybe it is for your consumer, so you don't break your consumer. Yes? That's a good question. You still have to do some communication. So it's not that the schema registry will know what schema the consumers are using. So if you want that, you need to use transitive if you want to be very sure, so you don't break ever again. But it's the thing is, this gives you more a more safe way to evolve your event data. You still, of course, need to communicate between producer and consumer, but much less, because you have a central place where your contract is stored, where you have the documentation, where you can enforce compatibility, which you don't have if you don't use any contracts at all. So it's an improvement against not using it at all. But communication is still needed, yes.
Any more questions? No, thank you, Jeroen.
Okay, nice. Bye.
In 15 minutes, we have Joran Barré here, talking about building an enterprise product on top of Spring Boot. And in the other room, I don't have anything at the moment. Just a second. Yes, accessibility. Chris will talk about what we make better for people with disabilities is better for everyone. So, again, to his interesting talks in 15 minutes.